Okay, this example on the upper left is simplify completely. We're asked to combine radicals, but before we do, let's review some of the operations on radicals. So over here on the right, you have radical A dot radical B. You're allowed to multiply radicals as long as the index is the same. And just to make a note, this is the index. N is the index. A is called the radicand. So in this case, radical A times radical B is actually, the index is 2. If you don't see a number, you assume it to be a square root. You're allowed to multiply, so radical A times radical B is radical AB. For the same reasons, you are allowed to divide as long as the index is the same. The radicand does not matter. So the answer would be the square root of radical A over B. Now, addition is a different story. So let's take a look at radical A plus radical A. You want to assume that the index is the same, which it is, but you also want to assume that the coefficient is 1. Well, what happens when you're adding like terms? Adding like terms, you are allowed to combine the coefficients. Well, 1 plus 1 is 2 of those things called radical A. Let's just take one more example of addition. Suppose you have negative radical A added to another negative radical A. Again, these are like radicals. The radicand is the same, and so is the index, and you wind up with negative 2 radical A. All right, let me erase this and begin again. Okay, simplifying radicals. In this case, if you're given a perfect square, then the square root would be 2. How do you check? You take your answer and you square it. If you wind up back to the radicand, Now, what happens if you have a number times a radical? Well, let's see what this produces. Well, this means 3 times radical 4, which in turn becomes 3 times 2, and the final answer is 6. Let's take another example. Suppose you have negative 4 times radical 18. Okay, well, this means negative 4 times radical 9 times 2. I'm going to simplify. So it's negative 4 times radical 9 times radical 2. And let's see what we get. This is negative 4 times 3 times radical 2, which in turn becomes negative 12 radical 2. And that is your final simplified answer. Okay, with this knowledge, we're going to go back now and do the problem that's on the upper left of the screen. Okay, so in this example, we clearly see that the radicands are different, which means we cannot add these radicals as of yet. Well, the most we can do now, if we're wanting to add them, is to see if we can get the radicands to be the same. So we're going to be in the process of simplifying each radical and see where it lands. Okay, so I'm going to rewrite. So we get negative 5 times radical 108 plus 1 times radical 48. All right, well, these are certainly not perfect squares, but is there a perfect square that is a factor of 108 and a factor of 48? Now, usually we like to pick the largest factor. All right, so let me explore. Okay, I'm going to teach you a little trick here. I certainly know that 48 is probably a simpler one than 108, so I'm going to do the 48 first. Perfect squares of 48 could be 4, could be 16. So I'm going to pick the largest one, and I'm going to rewrite it as 1 times radical 16 times 3. And this gives me a clue that the other factor is going to be a 3. I'm going to try now and go back and see if I can use a 3 here. So let's see, 3 into 108 is 3. Carry the 1 up, 36. There you go. It worked. So it's negative 5 times 36 times 3. And the trick is to match what's left in the radicand. So inside the radical, so we can actually later on add these like radicals. Okay, now I'm going to break everything up with dots. All right, it's always good to remember that you're multiplying. So it's radical 36 times radical 3 plus 1 times radical 16 times radical 3. All right, I'm just going to do a little light crossing out there. We know that we're going to be removing the radical sign because 36 and 16 are perfect squares. So it's negative 5 dot. Don't forget that you're multiplying. Dot radical 3 plus 1 times 4 dot radical 3. All right, a couple of more steps. Let's combine these two, and we get negative 30 radical 3 added to 4 radical 3. And now we finally have like radicals. The index is the same and the radicand is the same. I'm just going to combine the coefficients. Negative 30 plus 4 is negative 26 radical 3. And we are done. Notice we're done because radical 3 is no longer a perfect square, nor does it contain factors that are a perfect square. Okay, so let's continue on with another problem, similar problem. Okay, so in this next example, again, write down the problem, pause the video, then return, come back and check to see if your answer is the same. Okay, see you in a sec. Okay, I'm back and ready to go. All right, here we have 3 terms. And this process is exactly the same. The first question you ask yourself is, are these radicals the same? Now you're adding, and the answer is no. All right, so let's try to simplify if we can. Now there's a clue that if you see a radical 3 here, let's hope that the others can also be reduced down to a radical 3, but not sure at this point. Okay, so let's continue on. Well, there's nothing I can do here. Now I'm trying to trick you. The 9 is outside. It is a number that is not inside the radical. There's nothing to do here except multiply it times radical 3. Okay, now we have radical 27. Well, is there a factor of 27 that is a perfect square? Of course. It's 9 times 3. All right, plus 4. Don't forget the dot that you are multiplying. 4 times radical 12. I like to put the perfect square first, so it's 4 times 3. Okay, oh, this looks nice. So now we get 9 times radical 3. There's nothing else to be done. Now I'm just going to slowly break this up step by step. You don't have to do as many steps as I'm doing, but for demonstration purposes, I think it's wise that I do this. All right, so what did I do? Radical 9 times radical 3 plus 4 times radical 4 times radical 3. Again, I'm just going to put a soft line through the radicals that I will be removing and rewriting without the radical. All right. So now we get 9 radical 3 minus 3 dot radical 3 plus 4 dot 2 dot radical 3. And then finally, I can get rid of the dots and write it as 9 radical 3 minus 3 radical 3 plus 8 radical 3. The coefficients are now 9, 3, and 8. 9 minus 3 is 6. 6 plus 8 is 14 of these like terms called radical 3s. Now here we go again, just for fun. You're given an example. Again, pause your screen and come back, but remember to simplify completely. That's the trick. All right, see you in a minute. Okay, the solution to this problem. All right, I'm just going to put a faint line through all the perfect squares. Well, that's certainly going to go out, and that's going to go out. Okay, so let's see what we have now. So this is equal to 4.2. Again, I can write this as 4 times 2 inside the radical, minus 9 dot square root of 9 is 3, plus 8 dot radical 4 times 2. All right, well, the radicals are gone from the first term, so that's just plain old 8 minus radical 4 times radical 2 minus 27 plus 8 dot radical 4 dot radical 2. Again, I'm putting in every simple step. You could skip this if you feel confident. So now we get 8 minus 2 dot radical 2 minus the whole number 27 plus 8 times 2 dot radical 2. Let's clean it up a bit before we start combining like terms. So we get 8 minus 2 radical 2 minus the number 27 plus 16 radical 2. Are there any like terms? You bet. We get whole numbers and then like radicals. We can certainly combine these like terms. So 8 minus 27 is negative 19, and then we have negative radical 2 plus 16 is positive 14 radical 2, and that's as far as we can go. These are unlike terms. Okay, I have another just for fun. I hope you can handle it. So here's another just for fun. Hang in there. Okay, here's your second just for fun. Again, try the example, pause the video, and come back, and let's see how you do. This one has some, maybe riddled with some common errors. So let's go see how you do. Okay, see you in a minute. Okay, like terms. Well, we have x squared and x squared. It has nothing to do with a radical. They are simply collecting like terms. X squared plus x squared is 2x squared. 3 radical x minus 4 radical x. These are like radicals because of the x term. And you have 3 minus 4 is negative 1 radical x. And there is your final answer. All right, common errors. Be careful when you're adding x squared plus x squared. All right, these are like terms. You simply combine the coefficients and maintain the same power. So the common error would be to write, and do not do this, the common error would be to say the answer is x to the 4th. So this is incorrect. This is the do. This is the do not. Right, definitely, when adding like terms, combine the coefficients. Never change the powers.